Hello everyone, in this video we are going to look for what exactly the representation technique for the convolutional code. Earlier we have seen introductory part of the convolutional code, then what are the format for the convolutional code, then the representation for the state diagram, then the code tree diagram, even we have seen additional one, that is the polynomial representation. Now we are going to see exactly the trellis diagram which can be used for the representation of convolutional code. We are concentrating on the same convolutional encoder circuit which is simplified for this particular circuit. So it can be written like this. So this circuit we will just consider for the purpose of decoding as well as let's say for the encoding. So first of all we will just check out how to proceed for the trellis diagram. Now as it is implemented by the trellis, that's why only the name is trellis diagram. So we have seen that how to prepare this particular state table from this encoder circuit as well as how to prepare for this state diagram from the state table. So let's proceed for the trellis diagram. So this is what the trellis diagram looks like. So when we analyze this circuit, we can able to formulate this table which is known as a state table. We analyze this particular circuit as well as the state table in terms of, let's say, the unfolded nature of the state diagram. So that is nothing but in short the trellis diagram. But how to go for the trellis? That is slightly tricky, not that much difficult. So if you just look at the earlier lecture, also you will find that how to prepare this table with the help of the circuit. Now let's see from this table how we can draw this particular trellis. Now this is the first stage of the trellis. This is we can say for the 0 1, this is for 1 0, and finally for 1 1. And when we combine all these, we are getting this kind of response from the further instant. So here the representation is for the continuous line. This is what the representation we are using. It is when the input bit is 0, continuous line is used. When the input bit is 1, discontinuous line will be used. So it is the same convention which we followed during the state diagram preparation. So let's analyze it. For 0 0, when the input bit is 0, output bits are 0 0, and the next state is 0 0. That's why this line is drawn from 0 0 and it is ending at the same level. That's why 0 0 to 0 0. And these red color bits, these are nothing but actually the output bits. So continuous line indicates it is input bit 0, discontinuous for input bit 1. Means for the 0 0, when the input bit is 1, output will be 1 1. That is what specified over here. And the next state will be what? 1 0. So that's why from 0 0 to 1 0, this is what the line we have drawn. So this line is the discontinuous line. Same can be analyzed for, let's say, the next state. For 0 1, when the input is 0, output will be 0 0. Means next state will be 0 0 and output bits will be 1 1. So that is what specified. See here, 0 1, when the input bit is 0, output bits are 1 1. That is what here. And the next state is 0 0. That's why this arrow is started from 0 1 and ending at the 0 0. When we analyze it for the input bit 1, so that is indicated by the discontinuous line. So for 0 1, when the input bit is 1, output bits are 0 0, and next state is 1 0. That's why it is directed over here. Same is for 1 0 as well as for 1 1. So when we combine all this, it will give this kind of nature. And that's it. That is what all about the trellis diagram. But the thing is, if I want to do it with the stage wise manner, then how we can draw it. Now this is what suggested for the ti to ti plus 1 instant. So let's proceed for writing the same kind of thing in terms of the, let's say, the input bit stream, that is called as a encoding for the given input bits. So for the next slide, it is well understood over here that when I write down it for the 0 0, for the input bit 0, it will be 0 0 itself. For input bit 1, it will be here. So from this particular diagram, it is quite clear that we have not drawn the trellis at the first stage itself. So if I call this as a first instant, so for the first instant 0 0 0 0 activated over here, as well as 1 0 is activated over here. It means from the next track we can go for analyzing the trellis from here onwards. Okay, now by writing this trellis everywhere, now the task is, let's assume that this is what the input sequence. For this input sequence we need to write down this output, but how to fetch this particular output bits? So if you just find here the first input bit is 1, so for the 1 the discontinuous line should have been followed, so that's why from 0 0 this discontinuous line is followed. Again, after reaching it to the state, let's say 1 0, then we need to analyze it for the input bit 0. Input bit 0 means continuous line, so that's why it is over here. So during the second instant this line will be tracked. So from 1 0 to 0 1, so this is giving the output bits. So 1 1 is the first output which is written over here for the first input bit. For the second input bit 0, we are following the continuous line, that's why it is giving the output as a 1 0. So this is happening during the second instant. So we may call this as a t1, this is t2, and let's say this is what the third instant. In the third instant, what is happening? Since we are at this particular point, from this point third bit is nothing but 0. So that's why for the 0 again I need to follow this continuously, because for 0 this is what the continuous line, for 1 discontinuous line has to be followed. So that's why for 0 again it is continuous line. So with respect to this line, if we just analyze 0 1, when the input is 0, is the next state, just check here, it is 0 0, that's why it is directed over here, and the output bits are 1 1. So the same output bits whatever mentioned with the red color, that is written over here for the third instant. So at the end of the third instant, means let's say at this particular point, we will have the output bits as a 1 1 1 0 1 1. In a similar fashion, let's say for the fourth iteration or the T4 time, it will analyze for the input bit 1. So once we reach at this particular point and the input bit is 1, so this is nothing but regarding the 0 0. So 0 0, when the input is 1, it is directed towards the 1 0. So it is directed towards the 1 0. So at this point the output bits are 1 1. So the same output bits are provided over here. So these are the output bits, and this has been continued over here, means next bit is 1, again 1, so follow discontinuous discontinuous, next is 0 means continuous discontinuous discontinuous continuous continuous. So in this manner actually we are getting this encoded output. So it is actually depending on the user how he shuffles this particular states. It may happen that someone may write 0 0, then 1 0 0 1 and 1 1. So it is up to the means user, or we can say the problem solver, how he shuffles all this, we can say the states. But it is not giving that much we can say the difficulty if we shuffle this particular states. Means one may write it 1 0 and then 0 1, but accordingly this must be the correct, then only the shifting will be the appropriate. So thank you everyone, this is all about the how to prepare the trellis diagram from the given encoder circuit, how to prepare the encoder output by writing the trellis diagram. So in the trellis diagram we can observe over here this black path. This is nothing but the encoded path. So in the exam also we need to write down this path carefully. So this path has to be either encircled like this in the exam, which will guide to the examiner that okay, you tracked it like this. So this is what the expected answer we can say for convolutional encoder circuit if we solve with the help of the trellis diagram. So that is what all about the trellis diagram. The same trellis diagram we need to use while solving the Viterbi's decoding algorithm. Means the same diagram is useful at the decoder circuits also. Thank you very much.